not able to be in presence right now at the conference, so I'm happy to give this online talk. We're going to talk today about the future of software. So kind of like a journey through time from the early days, or maybe from the days of a few years ago until the future and what's expecting us in the next decade or so. It's going to be pretty interesting. Some of the things that I'm going to share with you are available online if you would like to dig deeper into these topics. So please feel free to ask later on Pine, and I will make sure to answer all the questions and give further material in case it interests you. So just a few words about myself. My name is Jonathan. I'm the VP R&D at a company called Pine. At Pine, what we are doing is we are building AI agents for software development. So we are really dealing with cutting edge areas of AI related to software development. Pretty exciting stuff. Later I can expand on this if you guys would like to. I'd like to start this journey throughout the life cycle of software with a story. So about 2 years ago, maybe 2.5 now, my co-founder Dan came to me, says, Jonathan, I have an idea. Now, at this time, I wasn't really excited because I know Dan, he always has his ideas. And the last time he had an idea, it cost us about $10,000 in AWS. So I wasn't super hyped. But then he continued and he messaged me, you know, Jonathan, it will be a great win or a terrible disaster. So, you know, I was intrigued, not gonna lie. And I thought, what can it be? Probably like a huge refactor. I have no idea. And before I tell you about what Dan's idea was, I want to talk about bicycles. So we're going to make a sharp turn now. If you are in the bicycle community, then you probably know that there's a type of bicycle called a fixie bike. It's the simplest form of a bicycle. If you were like on a deserted island and you had to reinvent bicycle for some reason, then that's probably what you would do. Just 2 gears spinning each other. If the wheel is turning, so are the pedals, etc. Now, why do people really love those fixie bikes? Why are those fixie bikes so common? So some people say, yeah, they're very light, it's very easy to maintain, etc. But if you really go into Reddit, for example, and you ask people, why do you like your fixie bike? People claim that when they are riding their fixie bike, they feel one with the machine. Their feet are moving harmoniously, you know, with the bicycle, everything is so smooth and fun, and it's like a different riding experience. Amazing thing. Now, when I came to buy my bicycle, I wasn't really impressed by this description of the seller, and I went for bicycles with gears. We still have uphills and downhills over here. But something really hit a spot for me in this description of, like, you know, feeling one with the machine. Because, okay, I'm a software developer. I also work with machines of a certain kind. And there were also times in my life where I was, you know, working on a backend project and I was like working on it all night, and I got into this like tunnel of concentration, and I left on the other side of this tunnel 5 a.m. The whole code was refactored, everything was amazing. I felt like I was a pianist on my keyboard, you know, everything was so smooth. This experience was amazing. And I thought to myself, Jonathan, you know, the bicycle riders, all they have to do is just get on the bicycle and they feel one with it. But how do you, a software programmer, how do you make sure that you get to this like nirvana of coding, the flow, the holy flow that we all aspire to be in? How do we get to this state that we are in, you know, in good flow? Yeah, I guess you've all been there. So lucky for you and lucky for me, Dan had an idea. So now let's hear what Dan's idea was. I open Slack, I text Dan, okay, Dan, what was your idea? And he sends me, Jonathan, yep, we should delete the entire repo. Oof, you know, I was looking at this and my heart started beating faster. I started sweating. I started thinking about all the time we invested in this code base, all the bugs, everything. I was thinking, oh, I don't know, should I report this to someone? This feels a bit criminal. I don't know if this is like something you should stop when it's young. And while I'm pondering and my head is racing, Dan sends me another message and he says, you know what? We need to write it all again from scratch. Whew. So first of all, that was a huge relief for me because I was like, okay, the script that reminds us to order lunch is not going anywhere. We are not going to starve. At least we have this win. And okay, Dan he has a breakdown. Who of us didn't have a breakdown? You are working on a complicated piece of code. It's too annoying. You just want to throw it all and start from beginning. And it happens because software is such a complex creature. So we've all been there. And I talked with Dan. We got into some kind of an agreement, etc. But then later that day, I went home and I was like, okay, what actually did Dan propose over here? There were two parts, very simple. There were two very simple parts to Dan's proposal. First, we erase the entire repository. Second, we write it all from scratch. Now, if we look at these two parts, okay, and we imagine for example, our daily meeting with the team. So imagine that in your daily meeting with the team, you start your day, and one of the engineers says, "Yeah, yesterday I wrote a new feature. Does this and that." Okay, what do we think about when we think about building a new feature? When we're here and build stuff, what do we think about when we think about building? So building and construction it's pretty messy, right? When we are building something, we expect a lot of noise. We expect a lot of dirt all around. We expect complete chaos. But then on the other hand, if you are sitting at the same daily meeting and one of your teammates says, "Yeah, yesterday I deleted some code. The system is still up. Everything still works. Everything is still okay. But there is less code in the system." Right? Everybody is happy now, right? Now the code is elegant. Now the code is organized. Now the code is clean like we like it. And everybody leaves the daily meeting feeling like this. This is an actual picture, not a stock photo of our team. Because guys, what feels better? As software engineers, you've all experienced it. What feels better than taking a huge chunk of code, this massive amount of lines, and reducing them to just a bunch? If we take these 5 lines of code and convert them just into one, that's so nice. And yes, I'm a Python guy. I'm not going to be shy about it. So I told Dan, I like what you're saying. I understand what you're saying, but let's make an agreement between us. We don't need to be crazy. Okay, we don't need to delete the entire thing. There are some steps in the middle. Let's do something in the middle. And we agreed that, okay, while we are going to continue building, maybe we should take some days and just focus on cleaning, organizing, and dealing with everything that all the tech that we developed over time. And we discussed this and we realized, how did we even get to this situation? How did we get to the situation that someone is so frustrated that they want to delete the entire thing? And our thought, or maybe the metaphor, was that code is kind of like it's an organic creature. So similar to organic products, it's very expensive. No, I'm kidding. Similar to organic products, it has a lifetime. It decays. It means that the moment you finish writing your piece of code, it already starts a process of decay. It already starts decaying. It starts becoming irrelevant, even if you are not changing anything. Just because our entire ecosystem is progressing, our code is becoming old and irrelevant. And this means that once we stop writing a code, or once we finished writing a certain piece of code, we need to take 2 paths. One path, we need to continue building more codes, more functions, etc., more features. On the other path, we need to start maintaining the code we just finished writing. We must do this. We must do these 2 things. And usually when I say this to developers, people tell me, "Yeah, but developers, we're mostly like this." You've probably seen this meme. We like writing new features. We like building. That's what we are all about, right? Why are we here at this conference? We like to build stuff. That's the fun part of it. We don't like to maintain and fix and all these nasty things. But if we're going back to bicycles, and with this I will wrap the bicycle metaphor. If we are looking at bicycles, you gotta spin both pedals to actually advance faster. Maybe you can pedal with one pedal. I don't know if you can do this. Most people who can do this are clowns, so that's just a hint. But you really need to put effort into both ways in order to keep moving. So Dan and I, we were pretty impressed. We were like, this was actually a pretty fun exercise, thinking about code as organic. Maybe there are more things that we should do, or maybe we should sit down and think about what else can we do to improve our code and to improve our experience as developers. Maybe we can actually enjoy this. So we were sitting and thinking, and nothing really came to mind. But then, after 3 days, I get this message on Slack. "Jonathan, I have an idea." Whew. So you guys you guys get a feeling of what it's like working with them already. This time, I wasn't so scared because I knew, okay, maybe it's going to be this big dramatic thing, but let's see, let's listen what Dan has to say. And Dan tells me, we should make a web series. We should make a web series. We should go to all the biggest tech companies, interview their leading R&D people, like the VP R&D, the group leads, the team leaders, all the people that deal with software every day. They have been there, they have seen it all. Interview them and get their insights on how to build good software, how to build great software in today's era. And I told him, Dan, you're so right. This is exactly what the world needs today. The world needs another podcast by two men talking about software. This is what we are lacking. The world is thirsty for this type of entertainment. We must do this. And Dan said, okay, yeah, I see what you mean. I see what you mean. Okay, fine. Note taken. And we went each to our homes and kept thinking about what else can we do to learn about these best practices and how to develop software in a better way. And finally, after, I don't know, like 3 days, Dan comes back to me and he tells me, Jonathan, no, I'm kidding. That was the last time. Actually, after a few days, Dan calls me back and he tells me, Jonathan, you know what? I called these companies, I got in touch with them, they are all in, we are making this web series happen. AI21 Labs, who are leading in the race of AI, you probably heard about them, Wix, one of the largest suppliers of websites, and Tori, they are all in, they want to share their knowledge, they want to share their wisdom. That's actually something pretty nice about us in the development community. We are very open about open sourcing our knowledge outside. So it's happening. Let's make this web series happen. Let's bring more companies. Let's do it. And I said, yes, this is great. I love this idea. I love that we are doing this, but there's only a small problem, only one tiny problem. I have no clue how to produce a web series. I'm a developer. I've never done this before. So how are we going to do this? Now, lucky for you, producing a web series, or maybe even lucky for me, is a lot like making a cake, right? So usually, I don't know if you guys are after lunch or pre-lunch, but I hope you stick with me through these photos. So when we are making a cake, we need to think about three aspects. The first aspect is the pan, or maybe the format, I should say, right? Because in this like deep cylinder pan, we can't make a brownie cake, right? We need a format that really suits what we are trying to make. And Dan and I said, okay, we are making this web series for developers. We need something that's kind of like documentary, but with touches of humor, because eventually our job is pretty funny. There are so many things that can go wrong. There are so many frustrations in the day-to-day. Surely there's a lot to laugh about. So we're going to make this doco about software, kind of like documenting the status of today, how did we get here, what are the challenges, what did we solve, what did we not solve, and then put some slices of humor inside. The second ingredient is, or maybe the second component are the ingredients. Right? When we make a cake, we care about the ingredients we put in. We want to put the best ingredients. In our case, the ingredients are the speakers, because we are making this docu TV show. The speakers must be interesting. They must be captivating. They must be nice to listen to. And this is, I'll let you in on a little secret. This might not be the easiest thing to find in our community. Maybe you know this. And finally, the thing that makes a cake or a web series truly great, and some people usually give here some suggestions, etc. But the thing that really makes something amazing is a game of textures. This is a little tip for me to you if you are in the baking community. So everybody knows that what really turns a cake from, like, let's say a pound cake, a normal cake, to something more interesting is that when you have some differences inside. So if you have this chocolate mousse with some salt, or if you have the berries in the cheesecake, or the layers of chocolate between the chocolate sponge cake. All of this goes to say that we must put something a bit more into our TV show. So we said, okay, that's perfect. We already agreed in the format that we will have these comedic things. Let's just integrate it into the TV show or the web series. And that's exactly what we did. We went out, we went to these big companies, 8 of the biggest companies. We interviewed the leading R&D people who have been in the industry for more than 10 years, maybe even more than 20 years. They have seen it all. They've been there from the early days of HTTP until the modern day of React and every other framework you can think about. And these people shared with us their wisdoms. We asked them about everything that bothers them. everything that can go wrong in software development, every bad practice, every bad experience. And we asked them about the same subjects. With all the companies, we asked about the same subjects. So we kind of have like an image of how does software development look like in these leading companies, in these big companies. We took all of this material, about, I think, 100 hours of filming, 60 hours of interviews. We converted it all into a web series, pushed it out, and it was one of it is the largest web series about development right now in our country. So if we're looking at the data, and I want to share the takeaways from this web series with you. So this is kind of like where we start today. So we're going to talk about some 5 key takeaways from producing this web series, what we learned about software, about the state of software today, about the state of software in the past, and then we are going to jump into the state of software in the future, or where are we headed with software development. So as I mentioned, we did about 60 hours of interviews with 28 engineering leaders from 8 companies, some of the biggest names, and we tried to understand, hey, well, what's bad, what's wrong, how can we improve developer experience? Maybe that was the main thing, or the main question that we asked. Now, to talk about developer experience, we first need to define it. Because everybody has a different definition, right, for developer experience. I've heard so many. And some people say it's ping pong and pizza parties, and some other people say it's having beer at the office. But between you and me, we know that developer experience is much more than these perks, right? We are talking about maybe the best similar concept is user experience. Let's say a user wants to order a pizza, then how many difficulties are standing between them and getting this pizza delivered to their household? Or in our case, as developers, we want to roll out a new feature, we want to fix a bug. How many obstacles are standing between us and our desired purpose? So we asked this question to all of our interviewees, and we found out that, while analyzing all the data and all the responses that they gave us, that there are pretty much 81 blockers that can stop us between getting to our goals. So I'm going to review all the 81 with you today. No, I'm kidding. We reviewed them, we kind of ranked them, we try to understand what really matters, what doesn't matter, what is small, what is big, and take the 5 most important lessons on how to overcome most of them. And I would like to share these lessons with you. The first lesson, and there's a reason it's the first one, is that specifications matter. When we are building software and we are trying to create a good developer experience, specifications matter. And if we're going back to the metaphor of ordering a pizza, right? So let's say that our user wants to order a pizza, but they just call the pizza center and say, I want a pizza, and that's it, no specifications, nothing gets to the seller. You might get the wrong pizza. You might not get the pizza that you liked. And in development, it's more or less the same thing. After this talk, when you go back to your teams, try to look into your development process and see, like, okay, do we do these specifications? Do we actually do we make sure that we are planning before we are executing? Because it can save you a lot of trouble. It can save you a lot of bad experiences. And the best teams that we interviewed, or the most happy teams, said that they really invest a lot of time in this step before they move forward to the next one. The second lesson we learned is about the tooling paradox. So you guys I'm pretty sure you guys use a lot of tools in your work. Maybe this is just a small glimpse into the CNCF bunch of tools that are available to developers. It's just a piece of the map, and this is only in one area, right? So there are so many tools out there to help us do our job, to get to a better solution, etc. But while on one hand, it really helps us that we have all these tools to do this specific task. On the other hand, it really makes it very difficult to get into a new project that you need to suddenly learn and get acquainted with 50 new tools, that one of them is used for a GET request, one of them is used for POST request. It's just too much sometimes. And it becomes a burden if we start using too many tools for our workday. And we found out that teams that use less tools are actually happier with how they work. So it's a bit of a paradox. While these tools are here to help us, we found out that actually teams that use less tools or found a way to use more tools that contain much more options are more happy about that. So I know that, we all have this like tendency to, let's try out this new tool, let's try out this new command line feature, let's try out this new thing that just came out, it's going to solve all our problems, it's going to be the best thing ever. We all have this tendency as developers. But maybe a good lesson here is try to keep it to a minimum. Don't exaggerate on the tools that you use. Okay. Third lesson that we learned is about coupling. I see that the slides are still not. Let me go ahead and share them again. My apologies for this. Okay, coupling. Yeah. All right. So going back to the pizza metaphor, imagine that every time you wanted to order a pizza, you had to call your, I don't know, personal trainer and say, hey, I need to order a pizza. What can I get, etc. Blah blah blah. And just this whole process would have been so heavy and so annoying. And you want to be independent. You want to be able to make the decisions on your own. Now, I know that this one is a tricky one because sometimes when we build software, we are inherently coupled with other teams. We are inherently coupled with other issues. So it's pretty difficult to say, okay, let's just decouple everything. But looking forward, or maybe when you go home now and you start building more and more software, try to think about how do I make my next piece of code as independent as possible, is that nobody would actually, or that people would be able to work with it without needing the assistance of someone else that depends on that service, that depends on that CSV, etc. It's a difficult task. It's not an easy takeaway, but I think it's a very important one. And we found out that the teams we interviewed really put a lot of emphasis on making sure that the systems they build are decoupled. And that's a big win. Okay. Lesson 4, knowledge sharing. I don't think there's a lot that I need to say about this that you guys don't already know. Besides just noting that this was one of the top 5 lessons. We all know that this is important. We all care about documentation. We all care about writing code that explains itself. Sorry. But we learned that if we actively invest time into knowledge sharing, meaning, for example, that in the retrospective meeting, take some time to tell, I did this and this feature. This is how I implemented it. This is the path I chose to take because ABC. And now the developers in your team are more familiar with your choices. That makes a big difference for them when they come to work on your code. And finally, the final lesson that we learned from this web series is continuous feedback, the importance of continuous feedback. When we are working on a software, remember it's an organic creature, it lives, it changes with every commit that we make. And it's really important to monitor how is our experience, what is stopping us, what is annoying us. Maybe over the course of like a few months, the build time went from 3 minutes to 10 minutes, and now every change that we are doing requires much more time from us. It's very frustrating. It takes your mind off one topic, brings you back to another one. It's really important to just be on top of that, just to understand, hey, what's bothering me? What's annoying in my day-to-day life? So I'm sure that when you go home now and you're, thinking about your own projects, thinking about the work in your team, maybe there's this small issue, something small that it's been bothering you, but you never really said, yes, that's worth the entire attention of the team right now. But I would like to challenge you and to say, yes, it is worth the attention of the entire team, because if it's annoying for you, maybe it's annoying for other people. And improving this small thing can mean a lot of gains in the future, or in the next days or in the next months for your team. Okay. So we know that software today is a bit difficult. We have all these challenges, right? We have the knowledge sharing challenge. We have the coupling challenge. We know that we have so many tools. We know that we need to do better specs because everything is so dynamic and changes all the time. And not to mention all the normal challenges of, let's say, writing tests and documentation and all of this. So where are we headed in the future? How is it going to look like in the future? We assume that it's going to be better, right? I hope so. I hope that you guys assume that it's going to be better as well. I think the first feedback that I get when I always ask developers, what do you think that the future is going to look like? Maybe some of them are too eager to say, hey, you know what, in the future, there will be no developers. So I'd like to start with a disclaimer before we talk about the future of software development, that yes, we still have a job. We still have a job for now, at least. but we still have a job in software development, but it might look a little different. It might change a little. It might not be the same thing that we are used to doing right now. And there's good reason to believe that we are still going to have a job as software engineers. And the demand for software is it's very simple actually. The demand for software it's climbing. The world needs more software. We still need to move containers, from China to the US. We need to move things around the world, and we need software to help us manage all of this. So we are going to need to build more software. There are more things we are going to need. We will need people to build them. Technology is making a huge impact on our world. So if I claim that software is still going to be here, what exactly is going to change? What exactly is going to be different in your daily life? There are two things that I want to focus on. The first one is new skills. New skills are going to be required, and this is actually a change that happens every time something changes in the world of software. When we moved from developing on our local machine to developing in the cloud, or developing, the cloud transformation, we had to learn new skills. Now everybody needs to learn, for example, how to talk to the DevOps guy. This is a very important skill. But jokes aside, you need to learn how to work with cloud providers, because this is just how software development looks like today. So now that we are moving into this new era of software, this future of software, we're going to learn again new skills. I think that the most important skill that we are going to learn is actually guidance. How to guide whether AI or your, let's say, junior teammate. And why am I saying this? Because you see, AI entering the game, and I'm sure you guys have all experienced it with GitHub Copilot and experienced it with Cursor or with any other tool that you work with. Something is really shifting. There's a real shift in software development. We moved from focusing maybe our entire time on writing code, maybe a bit less on code review and a bit less on specifications. We are changing now into a scheme where we are mostly writing specifications, code review a bit less, and coding a bit less. In a future where AI can really take our instructions and perform them very, very fast, write code super fast, write code that works, then what will be our job? It would actually be to guide it. We would be the people saying, hey, this is what needs to be done. This is what we are aiming for. Take it from here and let's continue. Now, this doesn't go to say that we will not deal with code, right? We still need to understand what's happening behind the scenes. But if we imagine these AI systems becoming better and better with time over the next decade, right? What we will do as humans is actually guide this AI on what we want to achieve. So that's a pretty big change, and it would require our skills to shift towards the area of writing specifications, guiding AI, or guiding people. It's in a way, it's kind of like becoming a development team manager. Now, I want to say, and this is something that might not be obvious at first sight, that the core of our work will actually remain the same. As developers, as engineers, our job is to identify, analyze, and solve problems. Right? We are getting this business requirement by the product manager, and we need to make sure that we deliver the actual solution for this product, for this problem. And we want to make it efficient, we want to make it fast, we want to make it, effective on memory, etc., etc. Today we are doing this, and we also have to code. In the future, we are going to get better. We must get better at just this, identifying, analyzing, and solving the problem, because someone else will take care of actually coding for us. So that's pretty amazing. And it might sound too futuristic for you. I understand that. But think in a matter of decade, think how much progress we can make in a decade on this front. Now, the new change, or another change, the second one that I want to focus on, as a direct result of this change of skills and this change of work, is the change of workflow. Right? We're going to change the way we work, not only what we do, but the way we do it. So if today, we get a task, we maybe start with writing some specs, planning, if, maybe scribble something in a notebook, and we get to coding. In the future, maybe what we are going to do is going to look a bit different. We are going to start with specifications. We're going to start with understanding how to solve this problem. We don't have to do it alone. We can do it together with AI or with any favorite tool that we would like to. We're going to break down the task, understand exactly what we want to achieve, etc., and then pass it to an AI that will execute it for us, which is pretty great. We'll take all the burden of, finding the missing comma on line 501 and fixing this. And we can only look at this once it's done, or maybe like 95% done. do the last mile, and ship it to production. So that's going to take a lot of the load of today's load off of us. Now, what exactly is going to happen here in the center part, like in the execution part? How exactly is it going to look? So for this, we need to understand what are AI agents? What exactly is going to take care of this task for us? So AI agents is actually not a new concept. It's an LLM set up to write iteratively with some goals or tasks, for example, to, I don't know, build a new feature or fix a bug. So maybe you are familiar with these two workflows, or maybe you are more familiar with the workflow on the left. So today you want to solve a bug, you go to an LLM, you tell it, hey, please do this and that. The LLM gives you a response. You say, this is not really working. The LLM pings you back. Then you say, I tested it, the test failed. The LLM gives you another solution, and then you say, yeah, you know what, thank you, I'm just going to code it on my own. And then you go to your IDE and you do your favorite code changes. But what I'm suggesting is that an AI agent would be more like the flow on the right. So imagine that you ping the LLM, you say, hey, I need to do this and that. The LLM can make a conversation with itself and proceed to give you the final answer. Now, in order for this flow to actually happen, we need a few core concepts, to introduce a few core concepts for an AI agent. So there are three concepts that I want to talk about. One is the tools. So in order for the LLM to complete some task, maybe it needs to use a code interpreter, for example. Second concept, memory. So we give it the LLM a task, it runs this conversation in its mind, but does it remember what it started with and what it's ending with right now? Where does it stop? Where does it remember what did I do what did I do the last step, etc. So for this we have short-term memory and long-term memory. Short-term memory is pretty much solved by most models with a context window. Long-term memory is usually solved with solutions like RAG. Maybe you've heard about those. And finally, the last concept that we need to introduce for an effective AI agent in software development is planning. When we get a task, we need to understand how are we going to do this? How are we going to attack this problem, with what steps, etc. We need to be able to reflect. We did this step, we ran the test failed. What exactly was the issue? So we need to do all of these steps. We are doing them today as humans. The AI agents will need to learn to do them as well. Now, how will it look like in a far more concrete example? So let's say that today I give an LLM a task, please write code for something. The LLM says, okay, here's your code. I say, I can probably improve this. So I'm taking the same code the LLM gave me and I'm saying, okay, here's a code for a task. Please check it and give me feedback on how to improve it. And now the LLM checks itself and tells me, there's a bug on line 5. You should fix it by ABC. So I tell the LLM, okay, there's a bug on line 5. You should fix it by ABC. And then I get the final version of my code. Now, some of you look at this and say, this is actually, this can be improved actually pretty fast. The only thing we need to do is to have this conversation instead of between me and the LLM, between another LLM and this LLM. So I would say write code for task. The first model would say, okay, here's a code. The second one, whose purpose is just to fix the first one, says, there's a bug on line 5. The first one returns a new version. The second one maybe runs a test, etc. And so forth, so on and so forth, until the first one decides, okay, I'm done. The code is okay. I will bring it back to my user. What we are talking about here is actually a loop form of a control logic. So we give the task to our AI agent. The AI agent makes an observation or a thought. What do I need to do? What is the next action to take based on this task? The AI agent makes an action. Let's say they write code or they run a test or they do something. Then they make an observation about the result of their action. And then they think, okay, I did this action. I got this result. What is the next step? What is the next action to be taken? So we run this loop iteratively until we get the result that we wanted, or maybe until we say, you know what, we ran this for too many times. Let's just give the result that we have right now. We can't progress any further. Now, with this form of agentic flows, you can imagine that something like testing, if you consider testing, or if you look at this red flow and you say, I know this is a test-driven development, it's a mythical creature that only few have seen in their lives. So this flow of writing a test, fixing it until it passes, and only then committing, it becomes very, very simple, right? Because we give the task to the AI agent, we tell it, hey, listen, this is what you need to do, this is the loop that you are going to need to do, and you only commit once you are done. So in a way, if we are thinking about this, once AI agents will be integrated into our workflow, then test-driven development can simply become development, because that's how we develop these days. And it's pretty interesting, but usually people tell me, yeah, Jonathan, that's fine, but in our company, it doesn't really look like this. What we do is we write code, we test that it works-ish, and then we commit. So this is the most common use case. And to this I say, yeah, you know what? The AI agents can do this as well. Maybe in the flow, in the loop that you define, you say, hey, write code, try to test it. And then if your observation is that it's like 80% pass, that's okay. Send me the result and I will continue from there. So we can always actually implement the same flows that we are used to, but with AI agents. Now, some of you might be wondering, yeah, Jonathan, this is all very nice and futuristic, but does it work? Is it actually going to change my workflows? Is it actually going to change my day-to-day? Well, I'm happy to tell you that yes. And for this, and the reason I am confident enough to say yes, and for this to understand why, I need you to get to know a concept or a dataset called human eval. So human eval is a dataset designed to measure the performance of AI agents. It consists of a bunch of coding tasks, just like this one, for example, this one in Python, where you have the signature of a function with the documentation, but we are missing the actual code. And the purpose of the agent is to complete the code with the right solution. So if we are looking at performance of LLMs over this dataset, and this is with the GPT 3.5 and GPT-4, but actually today we have much better performances, then we see that at the beginning, on the left side of the scale, we have zero shot. We have the model just getting the input, returning an output, and that's it. But the moment we introduce tools from the agentic workflows, like zero shot, like reflection, tool use, multi-agent, planning, we see that the performance jumps amazingly to the right side. And it even performs so well that you see that GPT 3.5 outperforms GPT-4. And this is great news for us because it means that we can make more out, we can get more out of simpler models, out of more of cheaper models in a way. And when I look at this, and when some people as well, maybe you look at this and you say, actually this is pretty interesting. So if this is actually going to work and we are going to have these AI agents that are going to write code for us, the end is near. Are we not going to use our IDEs anymore? Is it not going to be our main tool of choice? Because it's easy to understand why in code-oriented development, the IDE is the go-to tool. We spend the majority of our time writing code, spend the majority of our time debugging, we spend the majority of our time fixing those lines and functions. It makes sense that the tool that we use is tailored towards this type of activity. For example, an IDE. But if we are switching into a world where natural language coding is more dominant, where we're more guiding instead of coding, what tool are we going to use? What is going to take the place of the IDE? Interesting question. It's still unknown. It's still an unknown in our world, but I think that you will see that many companies today are trying to shape this future, trying to define this new tool that will be useful to us as developers. Now, AI today is already pretty useful, and you will find a bunch of tools out there that can do a lot of things for you, right? From generating technical specs and boilerplate code, testing, documentation, a lot of things. And I think on Twitter, you will find every week a new amazing example of how the game is slowly starting to change, how software development is already changing. And it's pretty amazing. But I think what the biggest takeaway that I want you guys to take from this talk is that AI is actually going to introduce the ultimate developer experience to us. We are going to have a much better developer experience. And that's the future. That's what the future of software development holds for us. It's a better future for us. It's going to revolutionize the software development lifecycle by helping us in the planning, in the testing, in the coding, and maybe even in the deployment. We are going to need to learn a bit more designing, a bit more problem solving and guidance instead of coding. So we will be free to deal with actual problem solving instead of debugging. We are going to be free to deal with the core business issues. And that's what most engineers really like to do. They like to solve problems. So we are going to do just that. we are going to start with this definition of a problem, how are we going to attack it, etc., and then take it over to the last mile. So we will still have ownership over what we produce. Maybe we will use tools beyond the IDE or beyond all of these, 150 tools that exist out there because the agent uses them for us. And in practice, we are going to accelerate our workflow much more because we will be able to work asynchronously. We give one task to one agent, another task to another agent, while we are out here enjoying a conference talk or maybe having a cup of coffee. Now, before I wrap this up, I want to give you a quote from Thomas Dohmke, the CEO of GitHub, and he said this a while ago. We are heading into a world where developers are more software architects and system designers. Right? So it's not something that we used to think about, right when ChatGPT came out or just like a few years ago. But this is actually the future for us. We are going to be better problem solvers. We are going to be more thinkers, if you will, or more designers, but not designers in the UX aspect, but more designers of technical solutions. So I find this promise amazing. To me, this is like really a game changer, and I feel like development will be it's already fun, but it's going to be much more enjoyable, and we are going to have much less frustration. And with that, I would like to end my talk, and I would love for you guys to reach out if you want to hear more about this, or if you're looking for extra materials about this. I hope that my talk left you with a positive attitude towards the future of AI and software development, and that you will be excited to try these new tools and kind of improve and change your workflow for the better. So thank you very much. My apologies for the slides at the beginning.